that way. There's some configuration that goes on, and then we've got firewalls and routing problems and DNS problems that all get in the way of our nodes talking to each other. So kind of the basics, I'm sure you're all familiar with IP addresses. There's, you know, probably know a little bit about routing, or you've seen like different IP addresses, different machines on different networks have to talk, you know, they have to send your traffic to a gateway to get to another network. You've got private IP addresses, which don't route on the public internet, so you need some sort of mechanism to, you know, to use a public IP from within a private IP space. I'm sure most of you are familiar with TCP and port numbers. You know, basically per application addressing within a machine. Network address translation, which is that layer that, you know, lets you use a private IP address and still talk to the internet. And then I'm sure most of you are familiar with DNS, which basically converts human readable names to IP addresses so that we don't have to remember that Willow Garage is 70.35.54.200. So every ROS node runs its own server. And it runs its own server on a random port. What this means for a lot of things is that when you're doing node discovery, your nodes have to, you know, they have to call up the ROS master to figure out where another node is. But what this means from a flexibility standpoint is that ROS doesn't require fixed ports to be assigned to anything, which means that you can do everything at setup time. And it means that you don't need to use the, you know, high priority low numbered ports for ROS, which is useful. In particular, there are 3 steps that happen when you do a topic subscription. Each of which involves a DNS query, each of which can break in its own way. So I'm going to kind of talk through that, and we'll see, and like this is the core part of where like 90% of your problems with networking run into is, you know, why can't I subscribe to this topic, you know, from another machine? Where is my data going? Why did it disappear? Or why can't my Turtlebot talk to my laptop? Kind of sort of problems. So in your ROS network setup, that's not the button. You've got some publisher node over here. When you set up your publisher, it calls up the ROS master and says, hey, you know, I'm advertising this topic scan, and, you know, my XML RPC address for my internal XML RPC server is at this host name and this port number. And that's all you do when you set up a publisher. And then when a subscriber comes along, the subscriber says, hey, I want to subscribe to this topic name. It calls up the master and says, hey, where are the publishers for this? The master comes back with a list of host names and port numbers for the XML RPC server on all of the publisher nodes. And then your node goes through and does a DNS lookup on the publisher name and connects to that XML RPC server and asks it, okay, I now want the TCP transport for this particular topic, right? What is the address for that transport? Because you've got multiple transports, right? I could just easily be asking for the UDP transport or a shared memory transport or whatever. And so the node then responds with another host name and a port number, which your node has to turn around, do another host name lookup, do another connection to this raw TCP socket, and start getting back serialized ROS message data. So you've got 3 DNS queries in here for the master address, the first query for the name of the remote XML RPC server, and then a third query for TCP, all of which can have problems, all of which can fail. So let's walk through, actually let's talk about the ways we can configure these things. So the address of the master is configured through the master URI. I'm sure you're all familiar with it. It's a host name and an IP address, or a host name and a port number. So, and then you can set ROS hostname and ROS IP to identify the local machine. And that's important because that sets the host name that your node uses whenever it publishes a topic. When it publishes a topic, it uses either the machine's host name, ROS host name, or ROS IP as the host name other nodes will use to get in touch with it. So, for example, if there's no DNS for your host name, and you try to do a subscribe, it's going to fall apart. But if you set ROS host name to your IP address, it actually works. So ROS host name and ROS IP are identical in the source code. They're, if you actually go read the ROS CPP and ROS PI source code, they are used identically. They are the same. It checks ROS host name. If ROS host name isn't set, it checks ROS IP. If that's not set, it defaults to the host name of the machine. So ROS host name takes precedence. And then we can walk through. See, there's a bunch of really good debugging tools we can use to introspect this system when things are going wrong. So we've got ROS topic info will give us some information about the topic. In particular, you can pull out what host name it's actually advertising into the master using ROS topic info. You can also use ROS node info to get information about a node. You can use ROS node ping to see if the computer you're running on can actually look up that host name for the remote machine and actually connect to that node. It's a very good connectivity test to see, well, okay, this node is publishing this topic, but I can't subscribe to the topic. Check to see if we can ping the node. You've got ifconfig that'll show you your IP address configuration on your local machine. Etc hosts will give you information, like that's your static host name mapping. So if DNS, let's say you don't have DNS, you can statically configure some of it. You've got resolve.conf, which configures your DNS configuration, like tells it where the DNS servers are, what your search path is, that sort of thing. And then man, which will give you man pages for all of the Linux commands for all of these things. I'm running a little long, so this is ROS topic info, right? We ask it for like information about a random topic. It tells us the type, which is kind of useful. What we're really interested in is this host name and this port number. So you can see, the host name I'm advertising with here is elwood.local. And if that host name doesn't resolve locally, then I'm not going to be able to connect to this topic. So that's kind of one of the key takeaways from this. We've got a bunch of advanced debug tools. Netstat lets you take a look at like what TCP connections are actually open. TCP dump lets you inspect TCP traffic as it's going by. IPtraf is another tool that lets you do more bandwidth style monitoring. Route lets you take a look at the Linux kernel routing tables and see like, well, I'm on multiple networks. How is this packet actually going to go out? Which direction is it going to go? Traceroute lets you trace the network. 5 minutes? Okay. And see which direction packets are going to go. And then the IP command is kind of the Swiss Army knife for Linux IP configuration. Everything from secondary IP addresses to advanced routing tables to policy-based routing. You name it, the IP command can probably do it. It is insane and awesome. So here's an example. Like actual debugging example. We've got two nodes. We've got a node A running on a host named alpha. We've got a node B running on a host named beta. Node A can publish to node B. This is no problem. But node A cannot subscribe to node B. What? This doesn't make any sense. How is this possible? How have we screwed up the system so badly that this happens? And it's actually just bad DNS. So if we take a look, we look at a topic coming off of node B, we see that the publisher name is beta, but if we try to ping beta, ping cannot resolve address, ROS node ping node B, and we see connection timed out. So obviously there is no DNS here for a host named beta. So that's why you cannot subscribe to this host because you can't actually do the host name lookup to get there. So the first solution to this is on beta, we set ROS IP to the machine's IP address. And now when we do a ROS topic info on this topic, we see, the IP address is, or the host name is now actually an IP. So we've shortcutted DNS completely, right? You no longer have to do a DNS lookup to subscribe to this topic. So now when we do like a ROS node ping, you can actually ping, you can actually subscribe, and it works. The second solution to this is to actually make that hostname lookup work by adding it to etc hosts. So we can go into our etc hosts file, we can say host, IP address 10.0.0.2 is beta, and then we see here, we're still advertising with a node name of beta, but now when we do that ping, because it's in our hosts file, beta actually resolves to an IP address, and we can do our ping. I'm going to skip NAT. So my recommendation for small labs that are having problems with this sort of thing is to set up a service called DNS Mask on your network. This is a combined DHCP and DNS server. What's really cool about this is that any client that does DHCP on your network gets its DNS address for free. What it basically does is when you do a DNS or a DHCP setup, you provide your hostname to the DHCP server, and it says, oh, okay, I'm assigning you this IP address, and over here on the side, I'm going to put that same name and IP address into the DNS for the network. And so, when that's done, every machine on the network can look you up by hostname and get your IP address automatically without any futzing around. This makes ROS work really, really well. So that's kind of the basics. Questions?